that I'm talking about. So if you see this graph, this is where bad things get bad. So here is the starting, right, of your coronavirus. Then you see this wedge-like graph. So this is one mutation that happened. And this mutation this gone for a small bit of time. Then it again got mutated somewhere here like this. Then there was a peak mutation and the cases rose when you had delta. Okay. Then again, you had gamma here somewhere. This was gamma. Okay. Now, if you trace back this Omicron, so Omicron is not getting from delta, neither it is getting from gamma or the other. So you always see a wedge, small wedges, right? So mutations happen. The natural mutation, it happens like this only. But this Omicron variant, it is coming somewhere from the 2020, right? It is coming from 2020. And it is rising up till here. It is rising up till here. And this is the kind of mutation it is getting. And it is very different from the other mutants of Omicron. That is why it is escaping the vaccines, and also it is infecting those who have already obviously, because if you got ill in around second wave, then you got ill somewhere here, right? You got ill somewhere here. And this mutant is of a previous generation. That is why people are getting hurt. If you maybe, so read chemistry, Chemistry is important if you want to tell about the structure of coronavirus and how it binds with lungs and how vaccines work, right? So all these things are important. Obviously, my concern is more with immunity rather than vaccine. So better be safe than sorry. Prevention is better than cure on those lines. So all of these things you will understand and you will appreciate more when you learn chemistry. So now in chemistry, what we are learning today, we are learning very simple things. What is hard water and how to deal with hard water, right? Yes or no? Hardness of water. We are reading hydrogen, na? You remember
Yes,
what we are reading, right? So in hydrogen, we are reading hardness of water. Hardness of water. Hardness of water. So any idea about hardness of water, why it happens? How to deal with it? Or how to know whether some water is hard? What is a hard water? What is a soft water? Something like that. Any idea? No? Okay, no problem. So hard water and soft water, right? Hard water and soft water. First of all, we can divide that into two parts, right? Water can be divided into two parts, I will say. Hard water and then we can also say there is another part which is soft water. Okay, hard water and soft water. So hard water, the problem with hard water is that it does not lather, does not form झाग, है ना? You know what is झाग? साबुन में जो बनता है ना? It does not form lather with soap, है ना? It does not form lather with soap. Instead, it forms a precipitate. That means it reacts, okay? Precipitate. Okay. And what is soft water? It forms lather with soap. Okay. It forms lather with soap. So what do you think? Do we want hard water or we want soft water for our daily purposes? For our daily use?
Soft water.
Yeah, we need soft water for cleansing, for laundry, for many things we need soft water. Now, so let me also try to get a photo, hard water, soft water. Yeah, so can you see the difference? Tell me.
Yes, sir.
है ना? Difference is
Yes,
very
sir.
visible. So now you can also check now whether your water in your home, it is hard water or soft water, right? You can also check that. What you will do, you will take a glass of water and then you will add some soap in it. Okay, so maybe add detergent on it. It will be better because आप साबुन ऐसे मिलाइएगा तो अजीब हो जाएगा. So add some detergent or liquid or solid detergent, powder detergent, anything. And if you have a glass, transparent glass, and you see there is foam or lather, it is formed above the water, and see how clean this water is. Okay, how clean this water is. And what is happening to this hard water? It is forming some precipitate. It's not forming, but this is extreme case of hard water. So in your home, you will not be having either pure hard water in the concentration. This is very hard water. This is very soft water, which does not have any impurity in it. Okay, now let us see why does this happen. Okay, why does this happen? So any idea? Any idea what is happening here? Why it is forming foam here and why it is forming some precipitate here? So basically what I can see, there is soap, right? Soap plus water. Okay, this is pure water, okay? Soft, I will say. So if soap is coming in contact with water, it should give lather. But soap, when it comes in contact with water, which is hard water, then it is forming some white solids, right? White solid. And in the language of chemistry, we say that something whitish type of thing is forming. We say that this is precipitate. Precipitate. Okay. Now there must be something. Now the soap is the same. We are changing just the water. So we can say that there must be something in the water, something in water that is reacting with soap to form the precipitate PPT, to form the PPT. Okay. Any problem till here? Any problem till here? Yes or no?
No, sir.
Okay. So anyone remembers what is the formula for soap?
Glycerin?
No. No idea? You guys okay. You guys don't remember?
No, sir.
Acha. So there is long chain of R group, right? There will be a long chain. This is in 10th class. I think this is in 10th class. So we'll have R, I will say R, long chain of alkyl group. Then you will have COO, and there will be COONA. Okay, COONA. So this is what? Sodium. So this is negative. Sodium is positive. So as sodium chloride or something. This is sodium stearate. STEARATE. So the original structure is like this. If you will have C17, H will be 35, COO negative, and Na positive. Okay, this is known as sodium soap. So if you see in the ingredients, you will see that there is sodium. So sodium is present in this form, sodium stearate. Now what happens? This water, it contains, now what will happen? This water, it contains some kind of ions, okay, some kind of ions, right? And those ions, they will be positive charge ions. They react with the sodium stearate and it forms COO negative, and those positively charged ions, right? Those positively charged ions. So they both react and they form the salt and they form the PPT, the precipitate. Okay, the precipitate. Now, what are these ions? What are these ions? So these ions are mainly calcium and these are magnesium. These ions are calcium, that is Ca2 positive, and magnesium. Mg2 positive. Now, when these two ions are present in any form, so they can also CaCl2 can be also present, right? Then you can be having calcium carbonate or magnesium carbonates, or magnesium sulfate. So any compound, any molecule, any ionic compound in which you can have Ca2 plus and Mg2 plus. If it is added as impurity, not added, but it is present as impurity in the water, that water becomes hard water. That water becomes what? That water becomes hard water. Fine. So right here, next point.
So why only calcium and magnesium?
Because only calcium and magnesium, they form PPTs. For example, here
Okay,
also you
sir.
can see this is also a salt, right? This is also a salt, but this can easily dissolve in water. This can easily dissolve in water, and this forms foam and not precipitate. Okay.
Okay, sir.
Next, write with me. Calcium, Ca2 plus and Mg2 plus are present in hard water, which reacts with stearate to form PPT. Okay, done. Now, hard water can be of two types. Hardness of water. It can either be temporary or it can be permanent. Okay. Now, temporary hardness is present if magnesium and calcium carbonates are present. Okay, magnesium and calcium carbonates are present, then it is temporary hardness. But if we have soluble MgCl2, or you can also have MgCl2, write some more example, MgSO4, you can have CaCl2. Now, if these types of salts are present, CaSO4, so these are soluble, and if they are soluble, they cannot be easily distilled, and they cannot be you cannot remove them by only boiling. So these are known as permanent hardness. Now, when you have permanent hardness, you have to do some kind of chemical reactions. Okay, you can have to do some kind of chemical reaction to remove these ions. Write this down, then we will write about the removal of temporary hardness and removal of permanent hardness. Done? Okay. Right, removal of temporary hardness. Okay, removal of temporary hardness. Number one method is by boil. By boiling. Okay, so by boiling, what is happening? If you have calcium bicarbonate, what's bicarbonate? HCO3 whole twice. If you heat this, then it gets dissociated. Okay, it gets dissociated. And what does it form? You will form Ca, CO3, which is solid. It will precipitate down. Plus you will form H2O and CO2. So CO2 will be liberated up, H2O will be inside the water only, and this will be as PPT. Now, if you have formed something as PPT, then distill it. Then distill the water. Or distill or filter the water rather, or distill, filter the water, then filter the water. You can filter the water. Similarly, you can have Mg, HCO3 whole twice. Again, if you heat this, you will form Mg, CO3. This will also precipitate as solid, and then you will form H2O and CO2. H2O and CO2. Now this is easy, that you just boil it and then you will get some solid. You can filter it out, and whatever is remaining, that will be your soft water. Okay, soft water if the permanent hardness is not there. So this is how you remove temporary hardness. There is one more method. Please write this, and I will move further on. Second is by Clark's method. By Clark's method. Now in Clark's method, what do? We add calcium hydroxide. Treatment of hard water with CaOH whole twice. With CaOH whole twice in suitable amount. Forms Ca, CO3, from CaCO3, okay, which can be further distilled, which can be further filtered out. So the reaction will be something like this: CaOH whole twice plus CaHCO3 whole twice. It is going to give you CaCO3, which will be precipitated, plus H2. Two calciums. Water will be 2 to 4 water.
Done, sir.
Done, all of you?
Yes, sir. Done.
Yes, sir.
Okay. Now, right, removal of permanent hardness. Now, the permanent hardness, it has all of the permanent hardness, whatever method we are going to study, it has very simple working, but the simple working, but the working inside, how it works, it is quite a complex thing. You don't have to know much about that. So just imagine that you have hard water, and here you have Mg2 plus ions, and you have Ca2 plus ions, right? So whatever water is present, what we will do, we will pass this through some chemical. We will pass this through some chemical, and this chemical, what it will do, it will absorb, it will adsorb, or it will react, right? Or it will react with, or it will bind Mg2 plus and Ca2 plus ions. Okay. And after it, whatever you will be getting will be soft water. Okay. So there are different chemicals which are used. Now we will be just knowing about those chemicals which are being used, and we'll also write some reactions. We will understand, we'll try to understand what is happening in the permanent hardness. What is happening in the permanent hardness?
What is
Okay.
the difference between adsorb and absorb?
Achha, adsorb and so if you have sponge,
Yes, sir.
and so sponge will absorb, it will absorb water, right? But if you have something like, let us say, wood, not wood, wood is not an example, good example. If you have, let us say, plastic, okay, then if you pour water on it, water sticks, it doesn't stick, rather I would say, but it gets placed over a surface, not like this. So that is known as adsorption. If something is happening on the surface, it is the adsorption. And if it is happening inside the substance, in the bulk, it is known as absorption. Okay.
Yes, sir.
So there's a chapter in your 12th standard about surface chemistry. There you will learn more about adsorption, various processes of adsorption, and how it depends on temperature and how it does not depend on many other things. Okay, so let us write the first method, that is number 1. Gans permuted method. Okay, so right here, let me, and then I will try to get a picture of this. In this method, sodium aluminium, orthosilicate, sodium aluminium orthosilicate, aka permutate or zeolite, is used to remove the permanent hardness. Okay, so what is this formula? Sodium aluminium orthosilicate. So it is Na2, Al2, Si2, O8, Si2, O8 dot some H2O. Okay, dot some H2O. There will be 5, 6, 7, some H2O. Okay, now it will react with Ca2 positive, and what will happen? This Ca, it get absorbed and it replaces the sodium atom. Okay, the sodium atom. So what is happening? That's permuted. It is for getting changed to. So you will get Ca. Now Ca, there will be only one Ca because Ca has 2 positive charge. Na2 will be removed, and you will be having Al2 Si. Okay, this will be Si2 O8, and there will be some H2. Let us write XH2O. Some number of H2O plus 2 Na positive. Now this Na positive, it will go to water, and it will be dissolved in water. And we know that sodium is not a bad ion, right? It is not a bad ion. So if you have sodium in your water, it is still a soft water. So let me see if I can get some photo. Gans permuted method. Okay, this is, I mean, similar to how we filter water. Okay, so we have hard water, and this hard water goes below. Okay, like deep inside. So water, obviously, it is what? It is lighter than the small stones, okay, very fine stones. So it will go here, then it will slowly, it will rise up. Now in this column, we have the zeolite, okay, the Na2, Al2, Si2O8, not XH2O. That is present here. This complete column, it is made up of the structure. Then while moving from the lower column and moving slowly higher up, what happens? The sodium, it is get replaced by Ca2 positive. Okay, it gets replaced by Ca2 positive, and the sodium, it gets dissolved in the water instead of the Ca2 positive. And here we get the soft water, and here we get the soft water. Okay, so as you can see that basic idea is simple, that you have hard water, and then you have something here. Then you pass this hard water from this something. This catches the ions, that is Ca2 positive and the Mg2 positive, and it gives you soft water, right? It gives you soft water. But this is whole mechanism how it happens. You don't have to draw this picture, okay? You don't have to draw this picture, right? Next, that is Kalgan's method. Kalgan's method, please write. In this method, sodium hexametaphosphate, this is NaPO3 whole 6. Okay, so this is sodium phosphate and a metaphosphate, and there is hexa, that means 6 is there. Sodium hexametaphosphate, known as Kalgan, is used. The Ca2 plus and Mg2 plus ions are adsorbed by Kalgan, and soft water remains. Okay, so it gets absorbed. Let me know if you're done.
Done, sir.
Okay. So again, you can see, right? Here also you have sodium. So what will happen? Sodium will be getting replaced. Okay, sodium will be getting replaced. Right, next, ion exchange resin method. Next one is ion exchange. Ion exchange resin method. Right. In this method, resins are used to remove the permanent remove permanent hardness. It is used to remove permanent hardness. So the process is like this. See, if you have, you will have some column. Okay, you will have some column here, and in this column there will be there will be some ions. Okay, so you want to catch which type of ion? You want to catch positive ions, right? So what you will do in this resin, you will put in negative charged ions. So this negative charge ion can be, mostly these are Cl negative ions and SO4 2 negative ion. Okay, SO4 2 negative. Now what happens? The water is poured over here like this. Water is poured over here. So we had Mg2 plus, right? So it binds with chlorine. It binds with SO4 2 negative. Okay, and what comes out is what? Soft water. What comes out is soft water. So that is means ion exchange. So what is happening? Mg2 plus and Ca2 plus, these are being exchanged by the negative ions. These are being exchanged by negative ions. So please write Ca2 plus and Mg2 plus, Ca2 plus and Mg2 plus ions are exchanged with Cl negative, SO4 2 negative ions, है ना? SO4 2 negative ions, and wait a second, Ca2 plus and Mg2 plus ions are exchanged with Cl negative, and SO4 2 negative ions are exchanged with cation, right? And Cl negative, SO4 2 negative ions are exchanged with the resin or NH2OH or NH2OH. So we have in the resin there are two types of substances. There are two types of substances. First of all, you have some carboxylic acid. So RCOOH is there. Now this RCOOH, it reacts with Ca2 positive, okay, and it forms what? RCOO whole twice Ca, and then H plus is given out. So this H plus, it goes to water, है ना? So it took Ca2 positive, है ना? It took Ca2 positive and it formed two water molecules, two H plus ions, and it went to water. Similarly, you have R NH2OH in one of the regions, and what does it do? It reacts with Cl negative. It reacts with Cl negative. It forms RNH2Cl. Okay, and it forms what is given out? OH negative is given out. OH negative is given out. It is when it is going to the water. Okay, so these two things which I am highlighting in yellow. Okay, these two things remains in resin. Okay, and then 2H plus and OH negatives, these go on with water. These go on with water. So that is how you capture the calcium and the magnesium salt. Now, instead of calcium, there can be magnesium also. Okay, instead of calcium, there can be magnesium. So write this down. So this was the last method. No? Yeah, this was the last method. So we are done with hardness of water. Now I want to talk to you guys about how we should proceed. Okay. So because now term 1 syllabus is done, this was the last lecture, term 1. So whatever is remaining is only term 2 syllabus. And in term 2, we are going to start with equilibrium is remaining. And what else remaining? Hydrocarbon is remaining. What else? P block, S block. So I was thinking I will start with equilibrium in Saturday, Sunday, and we will do P block. Okay. What do you think? What should we do? P block or S block first? or should we do hydrocarbon?
Equilibrium.
अरे इक्विलिब्रियम तो करेंगे ही,
हाँ, okay.
इक्विलिब्रियम तो करेंगे ही, है ना? We can start 2 chapters ना. अच्छा,
S&P block. I mean, so
S
you can consider S&P block as single chapter because we have
अरे
already learned some part in third chapter.
yes, but there are reactions, na? Reactions you have not learned. I can consider them one chapter. I can consider the complete chemistry as one chapter, है ना? But it's just about the time. Okay, I'm mainly concerned with time. Acha, you have your priority. Okay, you have your priority. Obviously, next class is on Tuesday. This 1 hour class. So on Saturday we are going to do equilibrium. Okay, Saturday and Sunday. Sunday there will be equilibrium. Okay, there will be equilibrium. Okay, next is what we have Tuesday and Thursday. So for Tuesday and Thursday, you have choices: S block, P block, or hydrocarbon.
Sir, S block and P block we can start first because they are small chapter and we learned some of them, right? So it will be finished faster.
हाँ वही तो बात है, ये तो ठीक है, ये आप तो कह रहे ठीक है, लेकिन अच्छा S and P block, these are not small chapters. Okay, you may think these are small chapters because these are boring chapters. आप लोग ने क्लास में ध्यान नहीं दिया जब आपके स्कूल में हो रहा होगा. Let me show you the syllabus. ऐसा लग रहा है आपको स्मॉल चैप्टर ना? So S&P,
Those effective nuclear charge ionization enthalpy will be included.
sorry,
No, sir, in S&P block, mostly effective nuclear charge shielding effect are included.
see here, S&P block. See, if I see S&P block, it is approximately equal to hydrocarbon. See, and also in hydrocarbon, I don't have to teach much because I have taught the term 1 syllabus now. So see, classification we did in term like the term 1 syllabus. Aliphatic hydrocarbons nomenclature is completely
Sir,
done.
I'm unable to see your screen.
Can anyone see my screen?
Yes, sir, I can see. Yes, sir.
Yes,
Shravya,
sir.
there must be a problem with your internet maybe. Okay, so maybe wait for a while. So nomenclature isomerism we have done, है ना? Then again here also nomenclature. See, nomenclature. Okay, then a nomenclature, right? There is resonance. So resonance also we have done. Similarly, so in this hydrocarbons also we have done many things. In hydrocarbons also we have done many things. But when I look at S&P block, if I look at S&P block, I can start this also. That is not a problem. But how much time it is going to take? General introduction, electronic configuration, occurrence, anomalies is somewhat we have done in the first element of each group. Diagonal relationship, it is done. Trends in the variation of properties such as ionization, enthalpy, atomic retain. Okay, this is done. Okay, S block I can complete fastly. Only trends in the chemical reactivity with oxygen, water, hydrogen, and halogen. Okay, fine. S block I can do. So I will start S block. Then in P block, electronic variation of properties, oxidation state, trends in chemical reactivity. This is something that I have to do. Anomalous properties of first element, this is already done. Chemical properties, okay, boron, physical and okay, for boron we have to do physical chemical property. This is important that we have to do in 14th element. Okay, fine, I can start S&P block. Okay, then I will start S block on Tuesday. Okay, fine.
The Thursday, right?
अच्छा आज तो Tuesday, Thursday, हाँ सही. ठीक है. So S block on Thursday.